My name is Dean Gesch. I'm a research physical scientist, work for the US Geological Survey here at EROS. What I do is work with applications of elevation data, what we call digital elevation models, or abbreviated DEMs, and it's a very useful geospatial data set for many earth science applications.
My name is Danielson. I work at the USGS Earth Resources Observation and Science Center. I am currently the CONID Applications Project Chief, and that work is all about the creation of these integrated coastal relief models where we merge the land surface topography with the subsurface bathymetry. That was a great project. It allowed us to test different remote sensing methods to create a topobathemetric elevation model. So we basically flew drones there using Phantom 4 UAS, which stands for Unmanned Aerial Systems, and we flew drones over 13 days. We collected all this high-res photography, and then we derived high-resolution point clouds from that photography using what's called structure for motion.
It's really just a fancy name for using stereo aerial photographs to measure heights of features on the ground or the land surface itself. So the term structure for motion, really what it means is the motion in this case is the motion of the platform itself. So what is popularly known as drones. So the motion in that case is the drone takes a photograph, camera is on board the drone, and then obviously the drone is flying, it moves, so that's the motion, takes a photograph of the same area on the ground from a slightly different perspective, takes another photograph. There you have stereo photography and can measure the height. Now what structure for motion does is uses many photographs of locations on the ground to refine the elevation measurement with that technique. It was a new technique for us to use, and it generated very high resolution, high accuracy elevation data of the land portion of the Majuro Atoll.
Flying LIDAR in the Pacific is really expensive because of the logistics of flying out there, traveling with a plane that far out into the Pacific. It takes a lot of funding and a lot of coordination to make that happen. This was a science project to see what we could do with different techniques and to do a project that was fairly feasible cost-wise.
They fly very low level, literally hundreds of feet above the ground. So the photographs that come from that are very detailed. If you looked at them, the individual photographs, you would easily recognize people and cars and bicycles and very small objects on the ground, different than the detail that you would notice from many satellite images. The closer you fly gives you that much more detail, which ends up being recognized or realized in the accuracy of the elevation model that's derived from those photographs. It will be used by local planners on the island. We collaborated with some of these folks when we were there collecting the data. One of our collaborators is Dr. Chip Fletcher, coastal geologist at the University of Hawaii. Dr. Fletcher is working with the local authorities in Majuro to apply this inundation exposure assessment, vulnerability assessment that is based on our elevation model to help with things like building codes, and trying to determine which parts of the infrastructure are more vulnerable, whether that's certain bridges or roadways, and that sort of thing.